Hello and thanks for coming, and welcome to an evolution of a cloud provider, Titus. I'm Corin Dwyer. I'm an engineer on the Titus team, and I focus primarily on the control plane and the scheduler.
I'm Tomas. I do everything he doesn't do. I've been working on the Titus cloud provider for now the last 2-3 years of my life. So this is what I do all the time now.
Okay. Let's get started. So today we're going to walk you through, first and foremost, what is Titus and how we've gotten to where we are today. Tomas is then going to walk you through how Spinnaker has integrated with Titus in order to make it more accessible to the end user. And then we're going to finish it up with just open Q&A. Okay, so what is Titus? Other than this cool little red robot guy, which, by the way, we have stickers. If you want some stickers later, feel free to come up and grab them. So Titus is Netflix's container management platform with a unified scheduler for both service and batch jobs. Jobs meaning more of the description or the definition of a workload, tasks meaning the container or the actual execution of that process. So our containers today have to be able to support both AWS as well as the Netflix ecosystem in order for you to run your workload within Netflix. So why is Netflix interested in containers? Just like the rest of the industry, I think it really comes down to 3 things. Our users wanted simpler management of compute resources, such that, let's say I'm a workload owner and I want to launch a container with 1 gig of RAM and, I don't know, 20 CPUs. You can't really do that very easily on most cloud providers, so this really gives the user more control in what their application actually needs. Users also wanted a simpler deployment packaging model such that they could build an artifact, run it locally, run it in their CI system, and eventually run it in production on the cloud. And users wanted a consistent local development experience. And what do I mean here is more on today, let's say I'm a Java developer at Netflix and I'm building a typical web service that powers something. I would most likely build my Java code within an IDE such as IntelliJ and just run it from the IDE, and that's how I would do most of my development loop. And then when it's time for me to run it in production, I'd probably build this into a WAR, bake it into an AMI, and then put it in a folder such that Tomcat can read the WAR and run the application. But on that AMI, there's actually tons of other things going on. There might be an Apache reverse proxy server. There might be some kind of process that's managing configurations. And you wouldn't actually know whether or not your Apache or any of these other things were configured until you were in the cloud. So a container here gives you the ability to actually run all of these things bundled together locally and be able to, I guess, iterate faster on those things that maybe are not your Java application. So we've been doing containers for a long time, or maybe not that long, but decent amount of time. Titus started out as a basic batch scheduling system back in late 2015. And in 2016, we started adding basic support for services, so nothing critical. In late 2016, we started adding still not completely critical, but more important services, such as like stream processing jobs, things that power analytics, stuff like that, to where it was important to the business, but it wasn't necessarily impacting customers. At the same time, we started testing user impacting services through the use of shadow traffic. These were Node.js processes, and more or less at the edge, we would proxy a request to the correct API server as well as this new Node.js process server. And we did that for a couple of quarters, and then in the second quarter of 2017, we actually turned it on live, and today most of the device-based requests actually go through a Titus container. So just to give you a sense of our current scale, we run about 240,000 jobs a day. There's over 1,000 different types of applications on Titus. We have 7 regionally isolated Titus deployments. For services, the largest single applications cluster size that I've seen has been about 5,000 containers. And we've tested it up to about maybe 12,000 in a synthetic benchmark. These containers are running on over 6,000 managed VMs by the Titus team. Each VM is a 64 CPU instance type, so that's about 384,000 CPUs. For batch, we run about 450,000 containers a day, and that typically runs on anywhere between 600 and 1,200 VMs that auto-scale throughout the day based on the demand. So the Titus product strategy has really focused on 3 tenets. The first one is, the most important, is developer velocity. The second being reliability of the overall platform such that you can run a container at any point. And lastly is cost efficiency. We also wanted to make it very easy for our users to take an existing workload running in an EC2 instance and be able to convert that into a container. And lastly, we just wanted to really focus on what Netflix needs and not necessarily the needs of everyone else. So to give you a sense of how Titus is architected or built, I guess I'm not going to go through all of this, but I wanted to walk you through a typical job submission request. So let's say I'm a user and I want to go through Spinnaker and I want to launch my web service on Titus. I'd probably go to Spinnaker, I would create a server group, Spinnaker would then issue a job submit API call to Titus, in which case Titus would receive that job definition, there would be a desired in that job definition, Titus would then create tasks based on that desired. It would then place or schedule those tasks to Titus agents and store this information in Cassandra and then send these requests through Mesos to the Titus agents, and then the Titus executor on the agent would then be responsible for actually running the container. Like I mentioned earlier, we really wanted to focus on making it easy for our users to be able to take an existing workload on EC2 and move it into a container on Titus. And one of the big challenges there is there's a lot of Netflixers that are used to operating and running their services in a very particular way. And we wanted to make sure that this was a very seamless experience. So we did a lot of work for making sure Atlas metrics appeared very similar. Service discovery works the exact same way. This information appears in ETA, which is used by a lot of systems to, I guess, discover that the application is running in the first place. So we wanted to make sure that, again, a user, after moving it, wouldn't have to relearn all of their operation and their years of just being a service owner in general. We also wanted to make sure that users didn't have to relearn the entire cloud concepts that they knew from AWS. So for every container launched in Titus, that container gets its own IP from a VPC subnet and its own set of security groups. It gets its own IAM role, and there is a embedded metadata proxy within the container such that when you launch your container and let's say you have a traditional AWS SDK, it's going to make a call to 169.254, 169.254. It's going to get that IAM role that you launched your container with, and all of your existing integrations will work as is. So, and what this really means is if I had an EC2 instance, I could bring my exact IAM roles and I can bring my exact security groups with me without changing anything else. The only thing that you would be responsible for is figuring out how do I go from an AMI to a Docker container, which for most of the company, it's pretty easy because the deployment artifact was a Java war. Another thing that I guess you could just uplift would be the auto-scaling policy. So we have integrated with AnyScale, the AWS product, such that you can take your existing auto-scaling policy and just move it over, and it will make the, I guess, ASG service will be making those calls into Titus to auto-scale the application. And finally, we also support using the AWS ALB, or Application Load Balancing product, to do a server-side based load balancer. Titus today supports 2 different types of jobs. I mentioned them earlier. The first one is a batch job or a run to completion workload. My favorite example workload on Titus today for this is the image ranking process. So if you go to netflix.com, there's actually tons of artwork all over the place. I'm sure you guys have seen it before. A lot of that artwork is not chosen by a human anymore. It's actually, what happens is you have a video source file and these still images are extracted and several computer vision processes are run over these still images, and then this process, the image ranker, more or less runs over this last pass and it determines what is the best image. So as you can see here in the picture, there's lots of faces, and I think the most important one is typically blurriness. Obviously no one wants to look at a very blurry image. So it more or less is choosing the best one algorithmically. The second type of job is the service job, and this is a run determination workload, more or less traditional web servers. This job is very similar to the AWS auto-scaling group concept, where you have a min-max desired, and the system is always trying to make sure the current number of containers in the system is equal to the desired. An example of this type of workload is Apache Flink. Our stream processing team runs Apache Flink to where they have an integration, say, they pull from a source such as Kafka, they transform the data, and then they write it to a sink, such as Elasticsearch or S3. All right, and with that, Tomas is going to talk about how Spinnaker is really leveraging this concepts in order to make it easier for users to directly use Titus.
Just as a show of hands, how many of you here are actually building a cloud provider right now? Like, how many of you are working on maintaining a cloud provider? Okay, so you should be familiar with this process then. So when you create a cloud provider, there's a series of steps that you go through, right? You figure out, how do I get the credentials? You figure out what things do I need to be configurable. You write a few caching agents that go through and index all the things that you want to remember. You then have to implement all the operations so that everything that you tell your cloud provider to do happens. You have to figure out what are the triggers that I'm going to use. So what are the things that are going to kick off my pipelines, whether they be Jenkins jobs, in our case it's the Docker registry. But the interesting thing about Titus is that we also added a Jenkins integration so that when our Jenkins job finished, they write out, for example, a properties file, and then that property file contains the image that is actually being deployed, for example. You got to write your health checks, make sure that if you're integrating with discovery systems like Eureka, those get taken into account when you're indexing your cloud provider. You have to take the load balancing or any other sources of truth into account, and then you integrate with all your external systems. Once you've done all that, you're done, right? Like, you got a cloud provider, it's beautiful, it's wonderful, it works. That's it, right? Like, it never changes. As part of this also, you need to map all your terms. So Spinnaker has a very kind of application, like very Amazon EC2 specific way of naming things. So you have to figure out, in this example, we have a server group, and that maps to the concept of a job in Titus. You have an instance that maps to the concept of a task in Titus. You have a load balancer that maps to an application load balancer. So once you've done all that, so you configure your credentials, your configurations, you've done all this work, your cloud provider is done, right? Right, like, it's it, that's it, right? Like, it never evolves, it never changes, it's done. So what we came to realize after working with Titus for maybe 2 or 3 years is that there are a few other things that then happen as your cloud provider passes the stage of done and is actually being used by people. So in this part of the talk, I'm going to really tell you about some of the examples that we ran into with Titus, and maybe use it as an example for you to think about when you're building your own cloud providers. So the first thing that we started realizing is that in terms of usability, in terms of the user interface, there are a lot of improvements that can happen when people start using the system. As you should be aware, the first thing that happens when you introduce more than one cloud provider is that you need to then start giving people the ability to choose which cloud provider to use. A lot of that happens automatically in Spinnaker when you issue more than one cloud provider, but many stage types don't support having more than one cloud provider. So you have to go in and audit all your stages now. And in here, for example, we have a canary deployment stage, and we needed to make sure that, first of all, the back end works with whatever the stage is doing, and then modify the front end so that now you have this option of choosing that separate cloud provider. Another thing that might start happening is that you might realize that a lot of these concepts, these values that you have for your stage UIs don't really apply to Titus or are different for Titus. So for example, in here at Netflix, when we configure a bake, we pass it a bunch of these parameters that might be very specific to the AMI image that's being produced. So for example, if you look at the store type here, it's EBS or S3, but when you're building for Titus, you're building a container, so that actually just goes to the Docker registry. So what we had to do also is reevaluate the questions that are being asked for each of the stages and actually build bake stages that make sense for Titus. So in this scenario, for example, we noticed that a lot of people were triggering Git commits and then just putting their Docker files inside of their Git repositories. So that's substantially different than an AWS approach. We also added the ability, for example, to add things like build time variables, which get passed to the underlying build system as arguments into the Docker build process. So then by kind of rethinking the functionality of some of the stages, you quickly realize that you have to examine your entire end-to-end pipeline UI to then fit within the container world. So that's another thing that you got to look at when you're looking at all your different stages and triggers when you're customizing that cloud provider. The use cases of Titus were really interesting compared to the AWS VMs. What we realized here, for example, was people would usually build maybe like 15, 30 clusters in AWS, and that'd be it. But for some cases that we found, like Flink, people would, like some of these applications ended up having 1,600 clusters. Some of these applications ended up having 3,500 instances. And that quickly becomes very difficult to manage if you're just looking at all of them at the same time in that Spinnaker UI. In fact, I believe that if at one point you could go to that page and just watch your browser crash, it was great. Right. So we had to come up with other interfaces that will allow us to scale the kind of navigation of these clusters. So here, for example, is the expanded cluster UI. So if you go to any application in Spinnaker and you have above 500 clusters, we won't show you all of the clusters. You have to go in and you have to select the list of clusters that you really care about, that you want to come in. And when you have 800 clusters, we found that this view was a lot easier to use than having everything shown to you at the same time. So that was something that we had to come up with for Titus because the use cases of Flink on Titus were very, very different than what we would traditionally use for VMs. We also link to external UIs that are provided by the Titus team. So on the sidebar, for example, there's a job ID and an instance ID, and when you click on any of these, they would point to the UIs that are provided by the Titus system. So in AWS, we try to hide as much of the AWS console details as possible because AWS console was frankly very, very difficult to use once you go beyond 300, 400 launch configurations. But in Titus, they actually had a UI that was usable and that was very helpful when you're trying to debug a series of containers crashing and so forth. So we linked to that. The Titus team also built our Docker registry UI that would give you information about the history of the image, where the images are available, the tags available for this image. And we then also decided to show them as part of the Titus UI. So when you're looking at your clusters, you can just click on the Docker registry UI and see how your image came about and how to use them. We have to make sure that all our performance and metrics links work with both AWS and Titus. So here's a link to one of our internal tools, and these are the same things that would be available to you if you're using AWS VM. But what we're doing here is we're making sure that all the metrics and all the links then work with the Titus counterparts. And then finally, we added features like being able to SSH into an instance by just copying that task ID. And this becomes very powerful when people need to come in and debug a container. So what they do here is they copy that link, they paste it on the terminal, and then you can log into this instance in case you needed to do any sort of debugging. So those are the kind of UI evolutions that came about once we finished the Titus container. People started using them, and they started requesting for features like that. Another thing that was really interesting with Titus, and it probably comes about just because Titus sits on top of AWS, so we reuse a lot of the AWS concepts. Spinnaker does not actually allow you to reuse an account name. So we couldn't set the test account, for example, to map to both Titus and AWS, so we had to come up with a naming convention. And in this case, we just name it Titus Test, and BPC is just before we had a different naming convention, but let's ignore that. But in order to demonstrate that that Titus resource that you're using was kind of using the Amazon information underneath, we had to also modify the UI so it was clear that when you chose Titus Test BPC, it would be deploying to the test account, for example. So if you see there under account there, we had to make it visible in the UI that this was the account that you were dealing with. And you would run into the same issue if you're building, let's say, an ECS provider, or if you're doing Amazon Lambda, because you can't reuse that account name. So now you got to come up with something in the UI that indicates that the underlying account that you're using is the Amazon account that you're mapping to. And this screen shows it a little bit more obviously, where if you're adding a load balancer in Titus, it would tell you that that belongs to the test account. Adding a security group to Titus, it tells you that it belongs to the test account. And the moment that you switch accounts, the underlying AWS account becomes visible for you. Otherwise, we're running into a lot of problems where people are just wondering, well, I have this Titus Test BPC account, and I don't know where it is, I don't know what it is. So in the UI, we try to make this as visible as possible. So those are all the UI modifications that we made. We started reusing a lot of the, so this is a feature called container migration. Do you want to explain what container migration does?
Sure. So basically, Titus runs on EC2, and we cannot do mutable upgrades for all of our components, so we have to rebake an image, and we have to figure out how to get all of the existing workloads onto these new instances. So the process in which we do that is called the container migration.
So what's interesting about the container migration is that when we implemented the container migration, we used the Spinnaker redeploy natives. So when an instance needed to be moved from one account to the other, you can issue a rolling push, for example. And then what the rolling push is going to do is you're going to take one instance, it's going to move it to the new container, you're going to wait for that to finish, to become healthy, you're going to terminate that instance and continue that until all the containers that need to be moved are then moved. Now in here, what we're able to do is use the backend orchestration functionality within Spinnaker to then enable this kind of migrations. What's interesting here as well is that then you take advantage of the health check. So if something registers itself as discovery, the container will be healthy in Spinnaker. So the platform doesn't really know that something is healthy. Titus doesn't know the discovery status, but Spinnaker does. So we can take full advantage of that. We can also allow people to specify that if whenever something needed to be migrated and they're managing their own deployments, just run a pipeline. And what this does is it just replaces all those instances in that cluster when that container migration happens. So this is an example of kind of a more robust type of integration that you can do in your cloud provider to take advantage of all the orchestration mechanics in Spinnaker and then leverage that in order to make your cloud provider migrations and other functionality like that better. So Titus does service jobs and batch jobs. And before, for AWS, all we had was service jobs. So what does batch jobs unlock for us? So when we implemented the Titus cloud provider, all of a sudden we had the ability to use this thing called run job, or like the ability to take batch jobs and make them as part of our pipelines. And
this became very powerful for us because Titus is inherently more secure than Jenkins. And that was the big insight for us. With Titus, you can lock down IAM profiles. You can tell something, here are the security groups that I care about. You can lock down permissions. You had better control over the blast radius of your deployment, right? So you can really lock down whatever each one of these batch jobs do. To set up a batch job, all you need to do is you run the batch job stage. This is the minimum amount of information that you need in order to run something in Titus. What's interesting is if you actually click on that show advanced option, you can actually specify things like IAM roles and security groups and so forth, which allow you to then really control both that and also kind of, it allows you to specify how often I want to retry this batch job and so forth. The other interesting thing that the batch jobs unlocked for Titus was the ability to then reuse property files, take the result of this batch job that I have run, and then inject it back into the pipeline. So what happens with Titus is after a Titus job finishes, you'll upload everything that it has done into, everything inside the logs directory gets uploaded into S3. So we can take advantage of this because we know that for that job, everything that gets written to the logs directory, we can retrieve and use it later on in Spinnaker. So what happens here is a Titus job runs, it uploads into S3, and then what Spinnaker can do when you specify this property file field down here is it's going to read that file from S3 and it's going to inject that value. So now you're able to use that value later on. So if your batch job created something like, I am going to merge this pull request, you can then write out whether that process was successful or not, or whether any change was needed, or a commit hash, or whatever else is necessary there. So then this allows you to really containerize a lot of your logic into Spinnaker. So in Spinnaker now, I can extend the idea of a batch job, and I can say, I want to trigger something from a cron trigger. I want to run a job. With the run job steps, I can chain two of these jobs together. I can run them in parallel, and then I can even use the results from that first Titus job and move it to the second one. And then maybe the third step there is I'm going to send out an email, but I can also do the third step there to be, and then do a deployment based on this kind of information. A more concrete example might be, I can run a cron job, I can run my test. When the test is successful, I can merge the PR, and I can email the user. And then at the same time, I also do an upload of an artifact to S3, for example. So we have a team at Netflix called Edge Productivity. And I had a conversation with them. And what they said that was really interesting to me was that this kind of workloads allow them to then really not rely on extending Spinnaker natively. They could just write these containers that had a little bit of functionality, that had very well-known outputs, and then test them out, like really iterate through Spinnaker functionality very quickly, because all they needed to do was push a container with functionality, run it, and then Titus ensure that things run reliably, Titus ensure that things run securely, and Titus allow them to have super fast velocity. So like the same process that they would use to write their services, they can now use to write their Titus batch jobs. And this became very, very powerful to us. This is also available in Kubernetes, and I suspect Lambdas kind of fit within that pattern, but it's definitely kind of one of the things that we found really unlocked the possibilities of Spinnaker within Netflix. Titus also allowed us to ensure a lot of the security concerns that we had at Netflix. So what does that mean? Because we had control over the entire Titus API control frame, what we're able to do is when a job comes in, gets submitted to Spinnaker, we can actually sign that job and say, this job came from Spinnaker and it's secure. Once that Titus job is launched, that Titus job then checks the signature that Spinnaker provides and is able to then access a lot of the secrets that are done within Netflix. So we have a system called Metatron, and what the Titus containers are able to do is they're able to talk to the underlying platform, get the secrets that they need, and pass them on onto the Titus job. So this kind of tight integration allowed us to really make our container platform very secure, and also allowed us to take advantage of a lot of the things that our security team wanted, to make sure that everything that is launched through Spinnaker is signed, but if somebody came in through the Titus UI and then just decided to launch a container, they wouldn't get the security permissions for that, and that enabled us to ensure that everything that went through Spinnaker was properly audited and secured as well. So that was one of the things that we had to evolve as part of this Titus thing, where there were a lot of internal initiatives, and then we had to build that into the platform in order to evolve this part of the cloud provider. So when I think back to kind of all the changes that we have made to Titus, it's normally within 3 categories, right? We had to make changes for usability reasons, like people wanted more clarity on different things. We added features, like somebody added the ability to talk to an EFS drive, so we need to add it to that to a cloud provider. But one of the biggest things that we were able to do with Titus is really make changes for performance improvements. As the underlying Titus platform evolved and it grew up and they started solving a lot of their own problems, we started taking advantage of a lot of these constructs that they built in order to make the cloud provider itself more performance. Now, this is something that might not be easy to do if you're working with something like AWS, where you request, give us a streaming API, and it takes a long time for that to happen. But because we have control of both Titus and Spinnaker, we're able to take advantage of those kind of improvements. And this is one example. This is the evolution of the way that Spinnaker indexes Titus. So there's an evolution here. We started with a REST API that gave you everything. Then we moved on to gRPC blocking-based API that allows us to separate jobs and tasks within this provider. And finally, we moved to a gRPC streaming API that allowed us to do real-time updates. And it looks like this. So the REST API, pretty straightforward. You ask Titus for something, it gives you all the jobs and all the tasks, and then you index them. When the Titus team introduced the ability to do gRPC polling, they also made changes to their interfaces, so they would separate requests for all the jobs and all the tasks or instances. So that allowed us to really kind of separate those into separate caching agents. We were able to use features within Titus, such as Eureka and federated endpoints. And also, we converted a lot of the one-off logic on REST interfaces into gRPC interceptors. So we had interceptors for logging, interceptors for authentication, retries, and so forth. Then we moved on to a streaming-based model of gRPC. So we listen and poll for changes within Titus itself. And the biggest benefit there was really the assurance that every update that happens would automatically update the cloud provider. And then this allowed us to get rid of the forced cache refreshes that were happening. In an actual deployment, we saw on average about 20 seconds being dropped from you issuing a request to your server being fully updated just by eliminating the forced cache refreshes. How does this look like? So in the REST endpoint, so the black bits are jobs and the white bits are tasks, right? So in the REST API, what would happen is you would come in and you would poll for the state of the world, right? Your caching agent would then come in and get the state of the world. You'll wait 30 seconds. You'll get the next state. You'll wait 30 seconds, and you'll get the next state. So in the second state, we see that another task was added to the end, and then in the final state, we see that 2 tasks were removed. In the gRPC polling world, we're able to separate tasks and jobs. So on the first query, you get all the jobs, and then and you get all the tasks simultaneously. That made the caching provider happen. That made the caching happen a lot quicker. So in the second stage, you then come in and you get all the tasks and all the jobs, and you see that additional task being tagged at the end. And then in the final polling phase, you see here we have all the jobs, and now we have the 2 tasks that come back. In the streaming world, what happens is you have that initial state, the same thing as the REST API. But then in the intermediate period, when that task gets added, the state within Spinnaker gets updated right away. And that then becomes visible immediately. When the next polling cycle happens, the first thing we're going to do is get the state of the world. So if we ever miss that event, we can still reconcile that. But then along the way, we can see that one task was deleted, and then another task was deleted. And then at that point, we're up to date. And then at the start of the next polling cycle, we just get that state of the world again, right? So by using the streaming API, we're able to then really improve the performance within Titus and Spinnaker. And that was kind of one of the biggest bottlenecks that we have struggled with Titus ever since the beginning. So by taking advantage of changes in the system and by coming up with novel and innovative ways of doing caching, we're able to then improve the performance of Titus tremendously. Maybe as a final note, when you're running one of these things in production, we found that here's the things that are really important and that really help when you're debugging and building a cloud provider. So the first thing is ensure that you have proper metrics and logging. There was an instance, for example, where we were indexing security groups in AWS, but we were getting the entire object for that security group. And so people were wondering, why does it take another 30 seconds for us to start a job in Titus? Through metrics and logging, we were actually able to figure out that we were just getting too much information of the security group when we were just checking that they existed. By eliminating that, we were able to shed 30 seconds of that entire process. And a lot of it was basically due to just having proper metrics and logging. Sharding of cloud providers. When dealing with performance, CloudDriver has a lot of functionality around being able to isolate the traffic that you're sending to each shard. And so as a performance characteristic, sometimes what we're able to do is, for example, send a lot of the non-critical requests to another shard of cloud providers. I know Cameron's going to talk a lot more about like what you can do to optimize Spinnaker in production. But when you're building a cloud provider, knowing that sharding exists and taking advantage of a lot of this functionalities that are built into Spinnaker to separate your traffic becomes very important. For Titus, what we found is adding feature flags for each new functionality as you're evolving your cloud driver, as you're evolving your cloud provider was really important. If there were bugs in the new provider, we can easily switch back to the old version of that provider. If we're adding things that we weren't sure what's going to have an impact of performance, having feature flags allowed us to kind of very easily just roll it up in maybe like test account and a test region first before moving it into our entire production stack. And finally, APIs are going to evolve, so having a strategy around evolving that API, specifying version numbers and so forth. You notice that there's a Kubernetes V1 and a V2 provider. Think about that when building your cloud provider. What is going to be hard versions that we map to, and what is going to build backwards compatibility? At Netflix, it was very difficult for us to shift away our APIs because there was a lot of automation built around the Spinnaker API. So what we had to do is actually keep the APIs at a lower level. So if I had to redo this again, I would have started with like a very robust versioning scheme for my cloud provider versions very earlier on, so that later on you're not thinking about breaking everybody that is using your cloud provider.